So if you go into our class section, come on, show me student mode. There we go. Look at the top. There's something called Azure for Education, formerly DreamSpark. I'm going to click on that. There's a document here that you might want to download. First time login instructions. You got to be able to click on those and download them and open them. So you'll need to go to Azure DevTools for Teaching website. Here's one link to it. I give you another. That's kind of weird looking. What happens if I click that? That doesn't look valid. It doesn't end in .com. But it works though. Okay, so you can get to it like that, or you can click the link that I've put in my announcement. Both should take you to the same place. It says the following screen appears. Good luck seeing this. This is itty bitty, but if we look at it, we do sign in. We click the sign in button. The following screen will appear. If you do not have a Microsoft account, you'll have to make one. It's not hard to make a Microsoft account. So we can give it a try. I think I've already done this. It might not work successfully for me. But if I go in and click sign in, no account, create one. Okay, I'm going to create one and try to link it to my raider.rose.edu account. jgthompson@raider.rose.edu. Hopefully I don't already have one assigned to that. Click next. It already exists. Anyways, if I typed that in and it didn't exist, it would create an email account, most likely. Maybe I can just do rose.edu. Maybe I haven't done that one yet. All right, and create a password. I wonder what this password is. It's suggesting one for me. I don't like that. And then I go and check my email. You know how to check your email. So here's my code. I have a 4-letter code. I checked my email for it. Type that code in. Your code's different. Looks like I have to type in one of these things. And then sure, why not stay signed in? Academic verification required. You're going to type in your school email address and you'll be able to get in. It'll have to be verified. It may not happen instantly. So it looks like this. Okay, you're not going to see this. I guess if it asks, you're going to choose school account. All right. Hope it doesn't give me too much grief about that. I'm going to stop the recording at this point. All right, once you click all the verifies and check your inboxes multiple times and copy all the codes in, we should be good to go. Start tour. What do I want? I want Visual Studio. Doesn't really matter which version you get, but you may as well get the newest one. So just go home, use your password, download the newest one. If you're here in campus and you have your laptop, you could go ahead and download it here, but then you'd want to use your desktop to do today's, type along. And you ought to be good to go from there. Just remember your Microsoft account because If Visual Studio thinks you have a trial account, you'll have to log back in with your Microsoft account to extend your trial. Oh, here's a key, a view key. This is how they've done it again. All right, so now I have a product key. You're going to want to take care of your product key. I think you can always come back here and download it again. This is different than it was on DreamSpark, but I might just copy that and email it to myself so that I have a copy of it. That way when I need to install it, I can just come back to my email and copy and paste it. And I'm sorry it's not super easy, but you can get it done, I'm sure. Just try to get this done as soon as possible so that you can do homework assignments as they come down the pipe. All right, I'm feeling good. I was able to get in. Y'all able to get in? Good deal. Good deal. All right. So, to the PowerPoint. There are such things as variables. Variables, why don't we just start some new notes? A variable holds a piece of data. A variable has 4 components. It's got a name, it's got a type, it's got a value, and it's got a memory address. Normally, we only care about the first 3, right? The computer assigns the memory address. The memory address is just where the data is stored that the variable is holding. Just like a mailbox, right? You have a mailbox somewhere, it holds some email. Well, we have a variable and it's holding a number, or it's holding a letter, or it's holding a string, something like that. So for example, if we do this, int x equals 3, if we add that line of code to our program, then we will see that the name of the variable is x, the type of the variable is int, because it says so right there, the value is 3, and the address is who knows. We don't care. We could find out, but theoretically, we have no idea. We're not just typing this in a notepad what memory address that would be stored at. What if we do another one? Float y. Well, its name is y. Its type is float. Its value, it's uninitialized. We don't know what value it is. It's got some random value. Whatever random value in memory was sitting there, that's what it's got now. So we can't use it yet. You have to put a value into a variable before you can use it. Put a value into, that's our English way of saying it. You have to assign a value. So put a value into, in other words, assign a variable a value before you can use it. So this is not going to work. I could not do math based on that. I could not do x is equal to y plus 2 because y has not been initialized yet. Broadly speaking, there are 2 numeric data types. There are integer data types, which are whole numbers, and there are floating point data types, which are numbers that have decimal points in them. Of the integer types, C supports breaking it down by a whole bunch of different options to how much data that variable can store. But one difference is that you can have signed types versus unsigned types. Now normally we think of data as being signed. X can be equal to -3, right? Y can equal -10, right? Signed just means it can be positive or negative. Unsigned equals positive only. It's very rare that you need an unsigned variable. But if you had to, you could do this. You could do unsigned int, z equals 3. That's just a variable that can never go negative. That's all that means. There's no such thing as an unsigned version of a floating point type, so we don't need to worry about that. You have local versus global variables. Local variables are defined inside functions. If you have this code, int main, and inside it you have int x is equal to 3, this is a local variable. And you don't have to take all these notes because I'm going to upload them. That means that this variable is not accessible to any other functions inside the code unless it gets passed to it somehow. And that's okay. Almost all the variables you create are going to be local variables. They are only accessible. There's a fancy word for that. They are in scope. That's a fancy word. Inside the function in which they are declared. Now, a global variable is defined outside of all the functions. Like you might do this. Float pi equals 3.14159, and then inside main, you could use it, right? You could say float radius is equal to pi times whatever, right? You know, area is equal to pi times, 3 times 3 in order to get the area of a circle, right? And then another function could still use that variable as well, right? Float circumference is equal to 2 pi r. Now, why am I using 3 in there? Because I don't feel like creating a variable called r. Okay, so this variable, since it's defined outside of the functions, since pi is defined outside of the functions, it's available to both functions. So it is a global variable. Now, area is defined inside a function, so what does that mean? What do you call it? Not a rhetorical question. I want somebody to tell me. It's not a global variable. It's a... Come on. Yeah, it's a local variable. That's right. It's a local variable, which means that area cannot be seen inside this one, and circumference cannot be seen inside this one, right? You have your own couch in your own room. You can't see that couch from somebody else's apartment, right? It's local to your apartment. So this variable can only be used in here, and this variable can only be used in here, but the global variable can be used between both of those. So this is global. This is local. This is local. So we have these math symbols. There's a fancy word for math symbols. Arithmetic operator. Addition, subtraction, multiplication, division. And then there's what's known as the precedence. Some things happen before others. What does that mean? I'm going to type some more notes. So math operators, or math symbols, we're going to give them a fancy name. Arithmetic operators. So like addition, subtraction, multiplication, and division. If you have, they're generally done left to right. So if you have this, x is equal to 3 plus 2, it's solved left to right. 3 plus 2. In this case, it looks like it would work the same way if it was done right to left. What if you have something like this? X is equal to 3 plus 2 times 4 divided by 2. Still done left to right, but just like you got to do the multiplication first, right? Okay, it's stupid. I'm doing 2 times 4 divided by 2, but you get the idea, right? That has to be done first. Multiplication and division have higher precedence, higher priority than addition. So this part of it has to be done first. Just like if you were doing math, from a math book and you saw that, or you saw this, you would know which part of the equation to do first, right? But we don't have to do that. It does it automatically. So, multiplication and division have higher precedence than addition and subtraction. So in the above line, 2 times 4 is done first, then divide by 2, and then finally that is added to 3. Now, if x is declared as an integer, or if these are all integers, the answer is going to be rounded down. Like if we did int x is equal to all that, then even if the division was supposed to make it a floating point number, like if we divided it by 3 and it wasn't evenly divisible by 3, then it would round x down to the next whole number. So in this case, the math would be rounded down since x is declared as an int. So we're just going to make some up. Int z is equal to 3 plus 5 times 2 plus 2. Int a is equal to 3 plus 5 times 2 plus 2 divided by 1 divided by 2. Okay, let's figure out what the top one is. What are we going to do first in this whole series? Which math symbol on the first one? Got to do the multiplication first. So this becomes 10. Then we can go left to right. 3 plus 10 is 12, plus another 2 is 14. Yeah. All right. Thanks. 15. I can't count. I'm glad y'all are here. Okay, and this one, I'm going to put semicolons on both of those because that's actually correct. This one's a little bit different. It's almost the same. Right, still got the 10 here. 5 times 2 is 10. Add 3 to it. That's 13 plus 1 divided by 2. I'm going to change this a little bit because, just because, I don't want to diverge off to something. So what's 1.0 divided by 2.0? That's 5. So this one had to be done first because of precedence. This one had to be done first. So we have 10 and 0.5 there, and 3 plus 10 is 13, plus 0.5 there would make it 14.5, but since it's going into an int, it gets rounded down because a is an int. You didn't have to worry about that in Python. Python didn't do any rounding unless you specifically told it to. C doesn't do rounding if you're trying to make a float out of it. So if I copy this statement here, float, f is equal to 15 plus 1.0 divided by 2.0. Okay, 15. 1.0 plus 2.0 is 0.5. That's going to be 16.5. No rounding because it's a float. There's another operator called percent. Well, it's not called percent. It's represented by percent sign. That means modulus. What does modulus mean? Anybody remember from Python what the percent sign means in a math equation? If you do a is equal to 3 modulus 2, what does a equal? It's okay if nobody knows, just let me know so I stop waiting. Thumbs down on that one? All right, all right. So what this means is 2 goes into 3 one time with a remainder of 1. That's modulus. So A is equal to 4% 2. 2 goes into 4 2 times with a remainder of 0. So again, percent means modulus and it means remainder. So 5 divided by, 5 modulus 3. 3 goes into 5 one time with a remainder of 2. Yep, you got it. I probably need to make up a little handwritten, worksheet just to boil that in to your brains. But y'all know what remainder is. It's just that for some reason in high school or whatever, we never used that symbol for it. But we do in programming. Why would you care about that? Well, here's why you would care about it. What if you had 60 ounces? O is equal to 60. And you wanted to find out how many pounds and ounces that was. Well, there's like I'm going to make it an easier number because my brain doesn't work that well. Like there are 16 ounces in a pound. So you could do this. Ounces is equal to 20 modulus 16. So if we divide 16 into 20, that's 1 with a remainder of 4. Okay. And then if we do our division, int ounces is equal to 20 divided by 16. That was supposed to be an equal sign. That was supposed to be 16. I can't type. There we go. 16 goes into 20, 1 point whatever, 1.3, 1.4. I don't know, but since it's an integer, it rounds down. 1 point whatever, rounded down to 1. So when we're done, that was not supposed to be ounces, dadgummit. I'm goofing the explanation. So if we print out pounds and ounces, we will see that pounds is equal to 1 and ounces equals 4. So if the recipe asks for 20 ounces of sugar, we know that that's really 1 pound and 4 ounces. That's an example of using modulus. And another one, just because we like modulus. You have 732 pennies. How many dollars and cents is that? Now, automatically in our head, we know that that's $7.32. But how do we prove that mathematically? Int pennies is equal to 732. We should even just type this into our code. I'm going to launch Visual Studio so we can, be proving this to ourselves. So File, New, Project. Or if you're stuck at home and you don't have Visual Studio installed yet, you could go to that link I posted for an online version of C++. I believe I posted it. Maybe I didn't. Let's go take a look. Oh yeah, here it is. If you didn't get Visual Studio installed, well, nope, that's not it. I'm going to post a link to an online version of C right now. Online C compiler. That one. Let's post a link to that in our announcements. We're just going to fill our page up with announcements. Try to get Visual Studio. But if you don't have Visual Studio going, then you can do your first several assignments using this one. So this is an online C compiler you can use when Visual Studio is unavailable. So you can even do it from your phone. How about that? It's exciting. I know I'm excited to do it on my phone. Not. Alrighty, so I can click that, it'll take me here, and I can write my little program here if I want. It's nice because it's already got all my boilerplate filled in. But I want to do it under Visual Studio, but I am going to need the boilerplate. I don't recall if I've made any boilerplate yet for this class. What is boilerplate? It's just the stuff that you have to type in every single time you create a new program. That gets tedious, so if we put it in a boilerplate, nope, don't see it yet. Okay, so we're going to type it in, but then we're going to save it as boilerplate. So I'm going to make an empty project, and it's our third lecture. So what did I do? I launched Visual Studio, and if you're doing it with Visual Studio, feel free to play along. If you're doing it with the online compiler, you don't have to do it this way. File, new project, choose C++ because C++ is backwards compatible with C. Choose empty project. For name, give it Lecture C, and don't let it stored in some stupid J.G. Thompson source repos directory. Well, it'll have your own initials there, right? So if you're at school, don't let it go there. Instead, choose Browse and store it in the Documents folder or in Documents Visual Studio so that you can find it more easily. So, Lecture C. Just storing it straight in my Documents folder. Okay, fine. I forgot that I have to click New Folder. How about that? New Folder. Lecture C. Select folder. Now I can go into that folder, click Select Folder, and that's where it's going to be saved. Much easier for me to find. So now I click OK. It starts churning a little bit, and it's going to create our project. Our project is going to be filled in on the right side in something called the Solution Explorer. If you don't see the Solution Explorer, like say I accidentally closed it, then you get the Solution Explorer back by doing View. View Solution Explorer. Now we need to add our file to the project. If we look on source files, there's no file there. So right click on source files, do add new item, and we're going to call it lecture.c. Whoopsie. I hit escape because I started typing it in the wrong field. I typed it in the location field. Change source.cpp to lecture.c.c. Everything's going to have a .c because that's the language that we're using. CPP is for C++. Alrighty, first line. Every one of my programs is going to have this. So # include less than, shift of the comma, stdio.h. Now we're going to add int main, parentheses in parentheses, curly brace, inside the curly braces, we're going to add printf, parentheses, quote, hello, exclamation point, \n, backslash being the one above the enter key. End quote, close parentheses, semicolon. If you're on a PC, if you're on Windows, everything's a PC, isn't it? A Mac's a PC, a Linux computer's a PC. Anyways, if you're on Windows, add this. Add system, parentheses, quote, pause. Now from now on, I'm not going to talk this through quite as much as I'm doing it this time because we've already done this a couple of times by now. So system, parentheses, quote, pause, end quote, in parentheses, semicolon. Alrighty. Now let's run it. I'm going to go to Build, Rebuild Solution. I didn't have to click that. I could have just clicked the green button that said local Windows debugger. But I like separating the ideas because we know that, oh, there was something else I wanted to do here. Something else I wanted to add, which is an ignore message that I forgot to put in last time. I bet I had y'all do it. I'm going to pause the recording while I go. There was supposed to be an extra line that I wanted to put into our boilerplate. We will find it at some point in time. The system call is inside a library that we would probably want to go ahead and include as well. Let me find out what library that is in, just for completeness sake. Because it gave us a warning message when we compiled it. Well, we'll leave that one alone too. It is working. If I run it, if I click local Windows debugger, it displays a message. Hello, press any key to continue. So it is working. So I want to save that code as boilerplate so that I can bring it back and copy and paste it, not have to type it each time. So I'm just going to highlight it all, right click, choose copy, and I'm going to open up Notepad or your favorite text editor of choice. I'm going to go to the magnifying glass and type Notepad or however you launch Notepad. Paste it, Control V like vehicle, and I'm going to save that in my programming directory as boilerplate. Boilerplate underscore c.txt. That way, anytime I need it, I can bring it back. Now, we don't want every program to print hello, right? So whenever we copy and paste our boilerplate, the first thing we're going to do is we're going to delete that line. All right, so we were going to change, if I recall, before that diversion, we were going to change the number of pennies into a number of dollars and a number of cents. So let's declare a number of pennies. Int pennies equals, 543. Now let's declare how many dollars there are. Int dollars is equal to the number of pennies. Int dollars equals pennies divided by 100. And int cents equals pennies modulus 100, the remainder after we do the division. And let's just print that out. Printf parentheses, that equals %d, a placeholder for dollars, and %d cents, \n. Now mine is starting to go off the page. Let me zoom off a little bit. After the quote, so \n, end quote, I need to put a comma and I need to put these two variables names, dollars and cents. So comma, dollars, comma, cents, in parentheses, in semicolon. Now it's scrolled off the edge of the screen, so I'm going to come back and hit enter there so that it's broken up, whoops, into two lines. They don't know how many pennies we had, so maybe we ought to add a printf statement that'll display how many pennies we have. Printf parentheses, quote, you have %d pennies, period, \n, end quote, comma, and the thing that's going to fill in the placeholder is the pennies value. All right. Now when we run it, hopefully it'll say $5.43 or whatever it's supposed to be. Yep. And you could do the same thing, like how many inches are there in a foot? Yeah, there's 12. So let's do int in, short for inches, equals 100 and I'm just going to make up a number. 1561. Now int feet equals in divided by 12 because there's 12 inches per foot. And int inches is equal to in modulus 12. Again, because there's 12 inches per foot. And again, we could put some print statements. And so on. Thousand grams in a kilogram, 5,280 feet in a mile. Right? There's all sorts of different ratios. 3 feet in a yard, and so on. I'll probably make a homework assignment where we use it, you know, this kind of thing to do some conversions like that. Now, why did I use different names here? I didn't necessarily have to do that. I'm going to show you and then I'm going to undo it. I could have done it like this, right? Inches is equal to, well, then I would have had to fix it everywhere. 1561 feet is equal to inches divided by 12. Inches is equal to inches modulus 12. That would work, but it kind of destroys my original data. After this line executes, I no longer have that 1561 in my memory anymore because I reuse that variable, right? I overwrote it with a result of another calculation. So that's why I called it in there and inches here, is so that I could keep that original variable without overwriting it. Just like I didn't call this one cents and this one cents, I wanted to be able to preserve this initial value in case there was something else I needed to do with it. Say we wanted to turn that many pennies into, you know, quarters in pennies. You divide by 25, and so on. Oh, it's burning me up that I've lost the notes for the first 2 lectures. All right. So what is a keyword? A keyword are the words that make up the language, not the variables. We pick the variable names. I created the variable names feet and cents and stuff like that. The keywords are the words that define the language. We've seen only a few keywords. We've seen the keyword int. We've seen not very many others. If we look at this, that's a keyword. That's the only keyword. The keywords are the things that are defined in blue. That looks like a keyword, but it's not. It's a preprocessor directive, which is slightly different. All right, but there are lots of keywords. Lots and lots and lots, as we see in this PowerPoint here. Auto, break, case, care. That's for holding a single letter. Const, that makes a variable that can't be changed. Continue, default, do, double, all sorts of these. Else, if, we've heard of those words, if and else. Go to, long, int, float. Yeah, lots of keywords. Ooh, got even another page of them. Oh, we should have one more return code down here. After system pause, and this should have been put in our boilerplate. I'll add it to the boilerplate next time I have the boilerplate open. We should have return 0 as the very last line of code we have. Every function that has a return type of int declared should return something. Now in Python, you didn't have to worry about return statements on your main code because the operating system was not calling your code. However, when you run an executable, the operating system is calling your .exe file, and your .exe can return an error code that the operating system could check. Now, we're not to that point. We're not checking for error codes, so we're just going to return 0 out of all of our programs until maybe later. So the statement terminator, you use a semicolon. You use it everywhere. No, you don't need a semicolon in comments. You don't need a semicolon in preprocessor directives. Preprocessor directives are the things that start with hash. We've only seen a few. We've seen hash include. In fact, that may be the only one. The beginning and the end block identifiers, what does that mean? You just don't put them after that and that, right? You don't need to do that, and you don't need to do that. That's kind of silly. Function definitions, and in general, anything that's preceding an open space, an open brace. What do I mean by that? I'm not going to put a semicolon here because it's before an open brace. And if I move the open brace up like that, it might look clear. Might not, because you're used to putting colons there after if statements and function definitions in Python, but you don't in this language. Every line of code otherwise, except for braces, and # includes and anything in front of a brace, is going to have a semicolon just to mark the end of it. And that's new to this language for the folks who are used to using Python, where you could use semicolons, but I'd bet $100 you weren't. Then there are what are known as escape sequences. This sure does kind of be meandering in order to get to the real programming stuff, but we need this background information because we need to know what a \n does. That's a new line, just like hitting enter or return on your keyboard. But there are other ones. There's \t, which is a tab. Then there's a couple little more cryptic ones. \r means go back, but not to the next line. Go back to the beginning of this line. Almost like backspacing, except it doesn't erase it. Then if you print more characters, yeah, it would erase what was already there. And then // means put a backslash there. /quote means put a quote there. And /single quote means add a single quote. I'll show you why you would need those. Let's print out some word, some phrase. Printf, parentheses, quote, my name is Mud. \n. Well, if you grew up in the 90s, my name is Slim Shady. There we go. Now, what if we wanted quotes around it? I put a quote there. Yeah, this is not going to work. I put a quote there. Why is that failing? And you were just telling me why. It's because it's treating this as the end of the string, right? That's the opening of the string. That's the closing of the string. And so it doesn't know what this is. Oh boy, my voice is going and I need to be talking until 10. So instead, we use an escape sequence. The escape sequence is anything that's preceded by a \, which is the one above the enter key. But by putting a quote there, we're just saying, okay, we're going to replace that with a single quote when we print it. And so I need to put after that \n another one. And it'd be a little bit clearer, right, if I spaced it out like that. But really, that's not how you do it in...
So you wouldn't put it after Slim Shady?
I goofed it up. You're right, exactly. That needs to be before the \n. Like that. Thanks. I would have tested it and run it and then got annoyed. There we go, right? Now it's got the quotes. And if you replaced the double quotes with single quotes, it would put apostrophes around it. Or if you replaced the quotes with slashes, I know it looks funny, ///n, but this gets turned into a slash when it's being printed, a single slash, and then that goes to the next line. Right, my name is Slim Shady with the slashes around it. I'll give you an example of why you would want to do that. What if you want to print out a directory path? Printf, parentheses, quote, my files are in C:\\temp \new files. Oh, and let's end it with a \n at the very end. All right, let's run it. it's not going to look good. Right? My files are in C. What did that \T turn into? It turned into a tab. \N? Nope, nope. That didn't work. It printed out a character turn instead. So to get that to work, I wish that would go away. I guess if I dock this down here, I might be able to get it to stop showing up. No, that's really not what I want either. It's close though. Come on. There. All right. So I can replace, I can make that \\. And although it looks funny, if you understand what computer paths look like when you see it there, when it prints out, it looks nice and clean. Now, if we didn't want to do that, anywhere you use a \, in a computer, you can also use a /. \/ is for Macs and for Linux and Unix. Excuse me. / is for Macs and Linux and Unix. \ is for PCs, but since PCs are the odd man out there, you can also use /, in which case you don't have to do the / business. But I'm going to go back and add them there. Why would you care about tabs? Well, you can kind of line up data with tabs, right? Just like you did on your typewriter if you ever took typing. Alrighty, debugging. Chapter 1, getting started with C. This is an example of a format bug. The format issue can be corrected by using the \n and the escape sequences. We need to put a \/ there. I don't see why we need // here. Anywhere in here. Oh, nope. Nope, I'm not seeing it all. If we had that and we wanted to make it look good, I don't see where we're going to use // anywhere. Maybe I'll do, I don't see it. But you would want to put that there. And you would want to put that there. And I guess we even want to put it there. And one there. Oh, I see why. Right there. Right? When it was trying to print it out. So you got to use 2 slashes to tell it. And same thing here. That would be one of those slashes, and that would be another one. Looks goofy, but it would work because the first 2 are turned into a single slash, and the next 2 are turned into another slash. And debug print statements. If you're trying to figure out what your program is doing, sometimes you wind up adding print statements just to see what in the heck it's doing, where it is in the code. In which case you add a print statement, but then you can put this command after it, fflush std out. Now, do we know what std out means? Do we know what fflush means? What fflush means is flush it. Send it all to the buffer. Because when you hit that print statement, it may not be displayed on the screen yet. It may be out in the memory waiting to be displayed on the screen, but when it hits this command, it forces it to be saved to the screen. Now, normally you think of flushing, fflush, as being used for files, right? We've got some data that we want to save to a file, so we write it out to a file, and then we issue the flush command to save it to the file. Well, you can also do that to the screen. And that's just what they're demonstrating here. You're not going to see me do that, but you could. We could go in here and add that up at the very top of our code if we wanted to. Printf, parentheses, quote, entering main, parentheses in parentheses, \n, end quote in parentheses, and then we could add an fflush call. Fflush std out. They show it on the same line, so I don't mind doing it on the same line. I guess they're doing it on the same line just to prove that we're printing something and then we're flushing it to the screen. Now, we don't see any difference. But the reason you'd want to flush it is because if the program crashed before it finished displaying this message, then we wouldn't get all of the message. And it's possible that could happen. Your output could be queued up in such a way that it's not all displayed on the screen at the same time. You'd just be kind of hanging out waiting to be written, especially if you're saving to a file. I'll add a comment here. You can use fflush to make sure that what you have printed will be displayed. even if the program crashes. I'm going to be leaving that out for the rest. But if you ever run into a certain situation where your stuff is not being displayed and your program is crashing and you need to figure out why, then you might have to start doing that. So just tuck it away in the back of your head. Alrighty, I think we're at the end of the chapter. Does everybody have this up and running? Did you get it up and running? Okay. I forget to ask that. Not. You're good? Oh. You could have been using this one back. Okay. Don't stress. Yeah. You can always download the notes at the end and it's copy and pasting it at work. Although if you miss a day and you're watching along with a lecture, I really don't want you just to copy and paste the notes. I want you to either type along or fill out a video review form. Alrighty, that ends chapter 1. We need a homework assignment based on chapter 1. I guess since I have my boilerplate still open, I'm going to add that modification that I wanted, which is to put a return 0 here. And also, I really would like to remember where the system call is defined. Let's see if I can find that. Sometimes you can tell where things are declared by right-clicking on it, like this variable here where I say in%12. And I want to say it wasn't defined right there above it, right? And we couldn't tell where it was. It was defined 100 lines up. I can highlight that word, that variable, right-click on it, and do go to definition. And it shows me where it was declared. Well, I'm going to see if I can do that to that system function. All right. Curious where that system function is defined. So I'm going to right-click it, or double-click it to select the whole thing, right-click it, go to definition. Well, right-click, go to declaration. Never mind. Phooey. Why is it that half the things I'm showing you today aren't working? Include library C system. Looks like it's in standard live.h. I believe that to be the case. So I'm going to add that to my boilerplate as well. # include less than stdlib.h. Add that to my boilerplate as well. So to be there next time I need it. # include stdlib.h. We can go and find out what's in stdlib.h. Maybe I could right click on it and say open document. I'm going to see if that works. I'm going to highlight it. It's going to look pretty cryptic. Highlight it, choose open document, and here's that header file. Oh boy, does that look cryptic. That is actually way above my pay grade. I don't understand what some of this stuff is doing. But that's okay. What if we want information that's more comprehensible by humans? I would go to like Google and I would type in stdlib.h and just find some documentation. So standard lib.h defines 4 variable types, several macros, and various functions. All right, that's telling us a little bit of stuff. A2F, turning an ASCII, turning a string into a floating point. All sorts of them. Don't need to talk about them all. Not going to talk about them, any of them. Okay. So I'm trying to show you that it is useful to poke around with highlighting things and then right-clicking on it to see where it is defined or what it is. I should be able to highlight the word INT and then just hit F1 and have it tell me some information about what an INT is. It's going to tell me the C++ version of it, but they're the same because C++ is just bigger than C. It's built on a foundation of C. Same with printf. I could highlight printf and click F1. And it's going to show me the documentation for the printf command. And we're going to see that there are several different variants of it. Okay? Whatever. We can scroll down and find out information about it. We might be able to find out what that %D means. It's giving some examples. It's showing that there's something called %X. There'll be other ones as well that we will start using. What if we mess up our formatting? Like, what if I've got it looking like this? Because I've been cutting and pasting a lot, and the program's still going to work. But it's ugly. The uglier it is, the harder to understand it is. You want your code to kind of look, quote, clean. Clean, easy to read. You want things tabbed over correctly. I know I had a student who just insisted that he never was going to put any blank lines in this program. That's fine. This program's ran. I didn't count off. But adding them, in my mind, makes them clean and easier to read. But my tabs are all messed up. There should be a way of formatting it quickly. I should be able to do a edit, select all, or you can just hit Control A to do a select all. And then I should be able to do an edit, advanced format selection or format document. And it should fix. Yeah, it lined it all up. Made it much prettier. Now, I would like for it not to have tabbed over these comments, you know, an extra tab, but it sure is better than it was. So do remember that you can do that. Control A, edit, advance, format document. The reason you're going to learn to like doing that is by the time you start nesting things several layers deep, and what do I mean by that? And don't type this because I'm going to get rid of it. Right? By the time you have if statements and you have while statements, you know, and you have other if statements like that, it's real easy to get confused to where your opening and your closing braces are. Now this application is actually drawing these little dotted lines here to try to make it look easy. But if they weren't lined up and we couldn't quite figure out where things were, we could do a project, edit. Why am I not finding it? Because I'm in the view menu. Edit, advanced format, and it would line my stuff up. Now when you choose that, it might instead line them up like that. Somebody tell me. Somebody highlight all your code and do advanced format and tell me whether it puts the braces on the same line or the line below. Did it do it on yours? Were you able to do a Control A to highlight everything in the advanced format? Okay, it left the braces underneath it. You'll see some programmers like to put the braces on the line above. I really like for them to be there. However, there's millions upon millions of programmers who like it to be there. There's also millions upon millions who like it to be on the line below. I think it's easier to understand if it's like that. This is called the block brace placement style, block formatting. If you put it like this, it's called something else. What is that something else called? I don't remember the technical term for it. It gets nicknamed the K&R style because Kernighan and Ritchie wrote the first documentation for the C programming language back in 1970, and that's how their book did it. All right, we're about done for today. Let's make a homework assignment. Write a program that will calculate the number of miles in feet if ft is equal to 10,000. Right, so you're going to declare a variable called ft, and then you're going to calculate the numbers of miles in feet from that. So hint, not that everybody has this memorized, there are 5,280 feet in a mile. So what are you going to do? You're going to do miles equals ft divided by 5280, and feet equals ft modulus 5280, something like that. So that's one of them. And then write a program that will calculate how many yards and feet there are in 1,000 feet. ft equals 1,000. Now that might only take you a few minutes. You might just modify the code we already have. I'd recommend you start fresh. Reference this code if you need to, but just start fresh so that you're not just copying and pasting and getting it done in 2 minutes. Yeah, even if you're, if you're looking at your old code, maybe it's only going to take a little bit longer, but just for the practice. And if it takes you longer, that's fine. And if you get stuck, text me and I'll help you. So that's our homework assignment.
Our original homework assignment, we're not doing that anymore with the Fahrenheit and Celsius.
We're still going to do it. It's just I'm going to bump the due date back because, right, very good point. You didn't get Visual Studio installed. How could you have done the homework? So we're going to change the due date on that. Let's go do that right now. We're going to make it do a week from today, just like this one's going to be. And while we're at it, why don't we make a Dropbox for today? All right, there's a Dropbox C. As soon as it finishes printing that save statement. Ooh, boy, is it taking a while. All righty. Should be there now. Dropbox C for you to upload today's homework into. Well, today's homework assignment. I keep saying homework. Today's lecture. Go ahead and upload it. You don't need to take a screenshot, except it's hidden. Excuse me. Now it's visible. So refresh your assignments folder. Just click on assignments again, and you'll see C. No, that's not the one. Why is that there? I need to delete these old spare assignments. There it is. All right. And I'm deleting that attendance thing because I'm not counting off for missed attendance. All right, if you refresh the assignments folder one more time, you're going to see the correct folder, which is called C Finish Chapter 1. And let's modify the due date for the homework.